All right, so this is the equation 3x plus 9 divided by 10 plus 3x plus 3 divided by 4 equal to 9. So what we've been talking about in class is that if we want to solve an equation that contains fractions, one way of getting rid of these fractions is to multiply both sides of the equation by the least common multiple. All right, so least common multiple. My denominators are 10 and 4. So I need to think of what is the least common multiple between 10 and 4. So let's look at multiples. The multiples of 10 are 10, 20, 30, 40, etc. The multiples of 4 are 4, 8, 12, 16, 20, 24, etc. So which one do they have in common? 20. And it's the first one that they have in common, hence least. Right? So what I'm going to do to this equation is I'm going to multiply both sides by 20. All right? But we're going to be careful about the way that we multiply. Because we mentioned in class, when we multiply a number to a fraction, we tend to think of it like this. Number to the fraction. We tend to say, well, let me multiply a times b and then divide that whole product by c. And I encouraged you in this class to think maybe of dividing a by c and then multiplying by b. So let's look at what happens. All right. So if I follow those instructions, then I've got basically 20 times 3x plus 9 divided by 10. I've also got 20 times 3x plus 3 divided by 4. And I've got 9 times 20, which is 180. Okay, now, rather than thinking 20 times this binomial expression, this is a binomial, by the way, an expression with two parts, I am going to think of 20 divided by 10. So 20 divided by 10 is just 2, which means all I need to do is double the binomial 3x plus 9. Same right here. Rather than distributing my 20, I'm going to think of 20 divided into 4 pieces. Well, that's 5. So I'm going to do 5 times 3x plus 3. All of this is equal to 180. And you notice, fractions are gone, fractions are gone. This is what we've been calling in class an equivalent equation to the very first one, which this should be a little more simple for us. Twice the expression 3x plus 9 gives me the expression 6x plus 18. 5 times this expression gives me 15x plus 15, all equal to 180. Time to combine like terms. I like to underline like terms so I can handle them one at a time. 6x and 15x combine to be 21x. And how about this 18 and this 15? They combine to give me 33. And all that's equal to 180. This equivalent equation is what we call a two-step equation because you're 2 steps away from the answer, right? So what are my 2 steps? I am going to take away 33 from both sides. That leaves me with 21x equals, that's 150, 147. And then all I got to figure out is how many times does 21 go into 147? I'm going to magically predict that that is 7. 7 times 1 is 7. 7 times 2 is 14, so 147. So if I divide both sides by 21, the answer is x equals 7. All right? Very last thing that I would do in this case is I would take my answer of x equals 7, and I would substitute it into my equivalent equations, any of them. The best one to substitute into is your original equation. So I'm going to do that using mental math. 3 times 7 is 21. 21 plus 9 is 30. 30 over 10 is 3. 3 times 7 is 21. Plus 3 is 24. 24 over 4 is 6. All right. So I'm left with, is 3 plus 6 equal to 9? Of course it is. I got the question right.